Inverting op-amp and inverting summing op-amp theoretical and experimental investigations with an introduction to the Espial Software made by Feedback Instruments Incorporated. We launched the Espial Software. Espial is a real word. It means the act of watching something. That's the exercise. Practical number 1. The jumper locations to physically wire this exercise are shown one at a time by pressing the Show Next button. These are the physical wiring jumpers that implement the first op-amp exercise. The first part of this video showed how to connect these jumpers one at a time. That's the input potentiometer. There's a picture of the input potentiometer, and that voltage occurs at that point. There's a block diagram that is being implemented in this first exercise. That's the op-amp and the feedback resistor around the op-amp and the input resistor to the op-amp. The blue probe signal enters the Espial software at that socket, and that jumper implements that. The yellow probe signal enters the Espial software, and that jumper makes the connection. The orange probe signal enters the Espial software at that socket, and that jumper implements that connection. Examine the Espial software signals. The data logger is like an oscilloscope that shows the blue, yellow, and orange signals. The bar display also shows those same signals, and the voltmeter shows only the blue signal. The signal coming from the blue probe. The blue probe can be moved to those numbered nodes, and it will indicate the voltage at that node. Compare the block diagram op-amp circuit to a real op-amp circuit. That's a block diagram, and that's an equivalent op-amp circuit. It's the op-amp, the feedback resistor, the input resistor, the variable voltage input uses negative feedback, and the positive op-amp input is grounded. The op-amp supply voltages are probably plus or minus 12 volts rather than 16. Op-amp output voltage is RF divided by R5 multiplied by V1 multiplied by -1. This is an inverting amplifier with a gain of negative RF divided by R5. And the output voltage cannot exceed the supply voltages, which is typically a volt or two less than the supply voltage limits. Another op-amp circuit adds and amplifies and inverts two input signals. There are two input signals. The output signal is the op-amp output. The output voltage is -1 multiplied by V1 times the ratio of those two resistors plus V2 times the ratio of those two resistors. This is a summing and inverting amplifier.